networks to connect to iSCSI storage. But even before that, we have to talk about the whole process of how ESX and vCenter handle networking in the virtual environment. Now, as you can see here, we call them vNetworks, or virtual networks. And there are two types of switches that are predominantly important with vSphere today. Those are standard switches and distributed switches. The primary difference between the two is that a standard switch, when you configure a standard switch, its configuration is for the specific ESX host that you're working on. And this is a great and small environment. They're very easy to work with. A couple of important things you need to know, but essentially you have to make sure with standard switches that the configuration on one host is equivalent to the configuration on all the other hosts. Again, great in the small environment. They get a little more challenging in the larger environments because as you got 300 hosts instead of 3 hosts, well, making sure that all those switches are correctly configured gets a little bit more challenging. So in this nugget, we're going to talk about standard switches and the networking policies that you can associate with those standard switches. We're going to talk about their capabilities, and then also here in just a minute, we're going to talk about the different ways in which you can configure those switches, not only in a VLAN configuration, but also in a direct connection configuration. I've got a kind of an image I'll show you here in just a second that will help you understand how that works. Then when we get into the click-by-click part, we're going to talk a little bit about how you can interact with those standard switches and create and administer VM NICs and port groups, VM kernel ports and network services, and all the other fun things that are required in order to get a switch into a usable configuration for how your virtual machines are going to need them. Before we get to, however, the whole interaction piece, what I want to do is help you in a visual format understand all the different kinds of networks that a VMware environment needs to be aware of and that you probably need to plan for as you're thinking about designing your environment. There are actually quite a few different kinds of networks that are important to be aware of. Let's assume that this is just an ESX server here. I've got just a basic ESX server here in the middle, and coming out of that server, I want to plug in all of the different networks that I need to be aware of so that I can support all the different needs my environment needs. Now, obviously, as you can imagine, a VMware environment is going to need to have some sense of production networking, right? These are when my virtual machines are running. They are, maybe it's an Exchange server. The Exchange server needs to talk to its Outlook clients over some sort of network, and that production network is generally the network where that communication occurs. Now, in most situations, that production network is going to be a dual connection minimum, and they're a dual bonded connection, so that if I lose one of those physical connections, well, then I have the ability to continue to pass that network over the remaining connection, or the surviving connection. Now, production network is important because obviously that's that communication path between my virtual machine workloads and the clients or the other pieces that they're working with in the environment, but that's only one of the many networks that you have to be aware of when you're thinking about vCenter's needs. Another one is actually the storage network. Now, for many environments, the storage network is a completely different network than the production network. And there's a lot of reasons for this. Storage traffic in many environments tends to be at a level, the amount of throughput that's required, that is much, much greater than production networking. And so if I'm running, for example, single gigabit connections, I may need to have a separate pair of connections that get my ESX server down to its storage. I separate these out in, for example, the single gigabit world because, well, I want to make sure that any sort of contention on this storage network is not going to impact the ability of my virtual machines to talk to their clients. So separating these out can be a good idea, again, to protect myself from overuse across any one of these connections. These two correspond to the two types of networking that are important for the virtual machines to accomplish the task that they need. There are, however, other networks that you need to be aware of as well. For example, a third network that can be important is what I'll just refer to generally as the management network. Now, we already saw an example of the management network back when we were talking about how you actually configure the initial settings with ESXi. ESXi likes it when you have a separate management network, and then that network is used for issuing the commands between vCenter server and obviously the vCenter client over to an ESX server. Now you might think to yourself, well, wait a minute, why do I need to have a separate network that the only reason for this network is to send those sorts of network commands or specific commands to an ESX host? Wouldn't that normally go over my production network? Well, it can, and in many environments it does. But from a security perspective, it's always a good idea to separate out those management network connections because of the types of commands that vCenter can actually send to ESX virtual machines. Now think about this. Do you have a data center? Probably. In that data center, do you lock the data center door? Sure. Why do we lock that data center door? Well, because there are items in that data center that we probably don't want people, messing around with. There are servers in there. Those servers have power buttons, for example. Those servers have connections to network and storage that we don't want someone accidentally or maliciously going in and unplugging or rearranging or doing something that we don't necessarily want them to do. So because of that, we actually lock that data center door. If I pass that management network traffic across my production network, that is no different than me having a data center and leaving the data center door unlocked. Now think about that. From within vCenter, I can power on a virtual machine or power off a virtual machine. These are two things that are generally, the power button on that machine is generally locked away behind the data center door. I can connect and disconnect various connections. And in the physical world, that's in the data center. In the logical world, that's in vCenter. So having a separate management network that routes to just the appropriate places in your network where your managers actually exist is important to ensuring that those high-level tasks, those actions like pressing the green VCR button to power on a VM or the red VCR button to power off a VM, well, ensuring that those can only be accomplished by the people who are responsible for actually accomplishing those tasks. There is a fourth type of connection that you can actually bring into an environment as well, and that's a vMotion network. This vMotion network is designed for when virtual machines need to pass but from host to host, that we actually separate out the process of transferring that information or the route in which that information transfers from one host to the other onto its own network, so that none of the potential congestion that exists on the production network or on the storage network or even on the management network will impact the process of that vMotion. I can hybridize the management network and the vMotion network together. However, sometimes that vMotion process may actually consume a lot of throughput, thereby preventing me from actually initiating those management commands that I need to. So I have, look at this, 2 connections for my production network, 2 for my storage, 1 for my management network, and 1 for my vMotion network. All of a sudden, there's all kinds of network cards that are required between my ESX host and all the different networks that it needs to support. All of these networks can be connected to via physical network cards. And again, if I have single gigabit connections, that might not be a bad idea to spec out my server with 2, 4, 5, 6 different NICs to support the networking needs of that ESX host. But it's not necessarily the case that you have to include these as physical network connections if your needs for throughput for these connections would allow you to combine those connections onto a smaller number of network cards. So let's assume instead, for example, that instead of using maybe a single gigabit connection across all of these, what I want to do is actually ease the process of dealing with the networks that I have. I don't want to actually have to deal with 6 different network cards in each ESX host. Instead, maybe instead of a single gigabit connection, I have some 10 gigabit connections, or 40, or maybe if you're watching this video a few years from now, we have 100 gigabit connections. Use of those types of connections, well, even when I've got storage and production and vMotion traffic that are passing across them, probably isn't going to consume the maximum amount of throughput that I have available. So in these cases, it may actually make sense for me to create one single pair of connections that are not at the access layer, but are instead at the trunk layer that connect into the rest of my physical network. Now, doing so requires obviously some magic that occurs at the network side, and that's kind of out of scope for this particular lesson. But understand that your network engineers, the people that are actually going to deliver these connections to you, could potentially create such a connection and then provide a series of different VLANs, all of which pass over the same pair of connections for the different types of networking that are required. For example, production and management and vMotion and storage all being over separate isolated VLANs and thus separate isolated subnets. So you have a lot of options in terms of how you might design your network for vCenter. You can do so in the physical world by creating lots of different physical connections, or you can simplify if you identify that your throughput needs are less than the availability that you have or the capacity that you have, and then consolidate those into perhaps a single pair or 3 or 4 bonded network connections together, and then separate them out logically using VLANs. Now for the rest of this nugget, I want to actually move away from the theoretical and into the practical so you can help you understand how VMware's standard switches can enable either of these situations to occur. So here we have vc.company.pri, and I've kind of squished over the left pane here, but you can see that ESX1 and ESX2 are currently connected in via the vSphere client. Taking a look at the summary screen here, I can see some general information about this host ESX1. I see it has one network here, even some storage stuff that's been configured, and fault tolerance settings here, which we'll talk about a little bit later. Now what I want to take a look at here at this point is the configuration tab that we took a look at not too long ago. In this configuration tab, there are a number of different elements here under the hardware node that we want to kind of pay attention to. One, for this nugget, is the networking node, and the other is the network adapters node. Now, if you recall, we actually added 3 VMNICs into this server. vMNIC 0, which is currently connected in for the management network connection, and then vMNIC 1 and vMNIC 2, which are currently connected to no switch at all. So these are essentially sitting unused on this host at this point. Here into the networking tab, we can get a nice graphical representation of how the physical adapters end up linking into the various physical networks that we end up creating. And the vSwitch itself is effectively this little gray box here in the middle. Anything on the right-hand side of this gray box corresponds to something that exists in the physical world, such as a physical adapter. Anything on the left-hand side of the box is something that corresponds in the logical world to some sort of port or port group. Now this is directly out of the box. I haven't made any changes to this other than installing it, the ESX1 server right into the vSphere client and then essentially clicking on this node. So what we're looking at is the initial configuration right as soon as you complete that installation of ESXi. In this configuration, the physical adapter vMNIC 0, the first adapter on this computer, is currently plugged into this vSwitch. And this vSwitch is, on the other side, plugged into a VM kernel port at 192.168.0.202, which is used for purposes of the management network. This is essentially the pathway by which commands are sent into this host for the purposes of doing whatever administrative things are required for this host. Also connected to this vSwitch is a virtual machine port group called vMnetwork. And any virtual machines that are actually on ESX1 could potentially be added into this virtual machine port group so that they would get whatever IP addresses are available to that port group. Now this is, again, the logical side of the network, and on the other side is the physical side of the network. I can, if I want, adjust the properties of both of these sides of the network by clicking on the Properties button and then viewing what I have or what becomes available to me here in the Properties screen. Remember, there were those 3 elements here. The switch itself, the vMnetwork virtual machine port group, and then the management network, which is used for vMotion and IP storage, and also for the management network connection. The first thing I want to take a look at here is the vSwitch. And you'll notice here that this vSwitch is currently configured with 120 available ports that it could pass out on the left-hand side of the equation. I also have the opportunity to change the MTU properties associated with this vSwitch. Now, if you're familiar with the concept of jumbo frames, the MTU size is generally set to 1500 by default, but we can set this up to as far as, I believe, 9000 to enable jumbo frames to occur across this vSwitch. Now, jumbo frames are one of those things you have to know for the exam. Some people turn them on in their environment because they find it gives them better performance, better throughput out of their existing network connections. But be aware that if you do turn on jumbo frames, you would have to change your MTU size here, and you would also have to change your MTU size at every hop along the way between this server and every other device that this server needed to connect to. Missing any hops would mean that, well, you would have to drop down to that original 1500 MTU size, and you would lose the benefits of jumbo frames. Now, on this vSwitch, in addition to setting the switch properties and the advanced properties, there are a number of different policies that can be set for defining how traffic is actually allowed to pass or how it is configured to pass across this switch. First are the security policy exceptions. There are 3 security policy exceptions by default. Promiscuous mode, MAC address changes, and forged transmits. And as you can see, by default, promiscuous mode is turned off, so it's rejecting promiscuous mode from occurring on this switch. If you have any kind of IDS or IPS, like an intrusion detection system, intrusion prevention systems, these systems sometimes require promiscuous mode to be turned on so that they can monitor the traffic that's occurring across other ports on that switch. But for the most part, in production, you'll probably find that you'll leave promiscuous mode set to reject. MAC address changes and forged transmits in high security environments may be set to reject. But these two tools, or these two approaches for how you deal with networking, are sometimes used by things like Windows clustering or by things like network load balancing in order to support one IP address actually being able to route to multiple different servers and multiple different IP addresses because of how the MAC addresses are spoofed from one hop to the next. So you can set these as you want on the switch side, or you can set them for individual ports as you see fit. There are some very minimal traffic shaping policies that you can set here as well, again, either at the switch side or for the individual ports. If you enable traffic shaping, this will allow you to identify the average bandwidth, the peak bandwidth, and also the burst size that occurs across that connection. Note that all of these are kilobits per second, except for the bottom one here, which is in kilobytes. Again, turning on traffic shaping is something you would want to do either at the switch level or probably more importantly for a specific port or port group if you find that that particular port or port group is using too much of the available throughput that you have. Lastly, over here we have this concept of NIC teaming. And with only a single network adapter connected here, there's not much that we can do now in terms of NIC teaming. In order to make use of NIC teaming, what we would have to do is first cancel out of here and also close out of here, and then add in an additional physical adapter into this switch. We're going to do this now by choosing the Properties button once again and going to Network Adapters. Now you'll see here I have a single vMNIC. What I want to do is add in a second vMNIC, that's vMNIC1 here, and click the Next button. You'll see that this vMNIC1 is now an active adapter, and I'm going to set a policy failover order here in just a second. If I click the Next button again and finish, it will ultimately add in vMNIC1 into this right-hand side of vSwitch 0. And as you can see here, vMNIC 0 and vMNIC1 are now teamed together so that they have essentially a multiple connection or a dual connection out to the physical world. Be aware if you do this that you'll want to do this only after you've configured the necessary steps that one needs to do on the network side. I'll call it the Cisco side of the equation. 802.3AD LACP, or Ether channel is another common name for it, is a Cisco protocol or a network protocol that's commonly turned on at the network side to let the network know that these two physical adapters have been teamed at the server side. If you've done that, or if your network team has done that, then you can go through and add in this second physical adapter. Once you've done so, you can go back over here to the vSwitch and click Edit and then back to NIC Teaming, and you'll find that you now have a set of active adapters by which you can set the load balancing and other types of policies associated with the NIC team. There are multiple different load balancing policies available. You can route based off of the originating virtual port ID, based on IP hash. This is a fairly common one. Source MAC hash, or you can use an explicit failover order, which would allow you to identify whether or not, or which adapter would be used first, and then which one would be the standby or failover adapter. Most people here use route based on IP hash. Again, that provides some of the functionality necessary for different types of networking traffic. We have the ability also for determining how we want to identify whether or not there has been a network failover or not. We can do so via link status or via beacon probing. I can notify the upstream switches if I want, and then I can identify whether or not I want to automatically fail back or not. These active adapters here can also be adjusted if I want. And for example, if I don't want to do load balancing and I want to use an explicit failover order, I can choose to move vMNIC1 down, and vMNIC1 will only be used at this point if there's a failure to vMNIC 0. So what this does is it gives me a little bit of options for how I will identify what the NIC teaming configuration will be for this switch. Now I'll tell you though that in this environment I don't actually have the necessary networking stuff set up. So I'm actually going to remove vMNIC1 from this vSwitch because I'm going to use it for other purposes here in just a minute. Removing vNIC1, as you can see, is a relatively simple process, and now I have the ability to use this physical adapter, just a single physical adapter instead of the dual physical adapters. So at this point, with that limitation in place, let's assume that we want to set up the storage networking connection so that we can support a separate connection to whatever storage we want to for this server. Now, I don't necessarily want to team the adapters here because, again, I just don't have the necessary infrastructure in place to be able to do that. But what I can do is, in fact, create another vSwitch down here at the bottom that I'll use to attach a separate physical adapter in to a separate VM kernel port for the purposes of what we'll use a little bit later, which is ESXi storage connection. Now what I want to do here is I want to click the Add Networking button. And what you can see here is I can add in either a new virtual machine port group or a VM kernel port. Now in this case, a VM kernel port handles the traffic for ESXi services like vMotion, iSCSI, NFS, and host management. I'm currently using that VM kernel port for host management up in the first vSwitch, vSwitch 0. If I click the next button here, you'll see that I can create a new vSphere standard switch. I can assign vMNIC1 to that vSphere standard switch, and I can assign it a network label. Let's call it storage instead of VM kernel. Now you'll notice here that I have the option of choosing a VLAN ID, and because I'm using access layer ports, I'm just going to set this to none. But if I had the other situation where I had a small number of bundled cables together that had multiple VLANs attached to them, well then I can identify a VLAN ID here if I wanted to. This would give me the ability to have a single pair of connections running multiple VLANs across those connections. When I have this set up, I can choose to use this port group, for example, for vMotion, or for fault tolerance logging, or for management traffic. Now in this situation, I don't want to use any of these services across this connection because I want to bind this specifically for use by my storage network. I'm going to choose the next button here. If I create that connection, I have to be able to give it an IP address because this is a VM kernel port. Now the IP address I'm going to use is 192.168.0.204 with a 24-bit subnet mask. And default, the VM kernel default gateway still remains 192.168.0.1. Remember, I'm going to be using this here in an upcoming nugget for iSCSI connections. And iSCSI connections at the initiator and at the target side have to have an IP address for them to be able to route traffic back and forth. So let me choose the next button here and then finish to actually complete the process. And you'll see now that I've created a secondary switch for use by storage with a second physical adapter, vMNIC1, that's going to be used for passing that storage. This is just the first step that's required to actually make that connection, and I'll finish some of the other steps in an upcoming nugget. I think it's the next nugget actually on storage. There is one last thing that we want to talk about here at this point, and that are the additional services that we might want to add in to this VM kernel port for the purposes of the management network. Let me choose properties here, and I want to go back here to the management network, and I want to choose edit here. You'll see that I have the same option of choosing a network label, management network, and the VLAN ID, which I can change or adjust if I want. And then down here at the bottom are the 4 services that are available for me: vMotion, fault tolerance logging, and management traffic. Let's assume that I want to actually combine my management traffic with my vMotion traffic over this same interface. I would do so by checking the box here marked enabled, and that would allow me to do both vMotion and management traffic over that same network card. If I choose fault tolerance logging, you'll notice that an error box will pop up here if I try to hit the OK button that reminds me that fault tolerance logging tends to have a lot of heavy bandwidth associated with it. And so it's generally not a good idea to actually turn fault tolerance logging on the same connection that's being used for other things like vMotion and management traffic. Now when I do that, I may want to go through and adjust, for example, IP settings, or I may want to go and make specific changes here and override the default settings that I applied to the vSwitch for security, for traffic shaping, or even for NIC teaming. You notice how all of these have the ability to override these by checking the checkbox and then putting in some sort of different setting here for this configuration. Now that I've done this, though, I know that I'm going to add and make vMotion operate over this existing management network and as well as management traffic. If I click the OK button here and close, you'll see that now I've configured the vSwitch appropriately for this server. Now you have to be very careful here, because once you complete configuring that for the first server, well, if you go back, you'll notice the second server does not automatically pick up that configuration. And so anytime you make any kind of configuration with a server using a vSphere standard switch, you're going to want to make sure that you take good notes on which configurations you've set so that you can apply those to all of the other servers that make up your vCenter environment. So what have we talked about in this nugget? We've really talked about all the different steps that are necessary to be successful with vNetwork standard switches. We talked about all the different capabilities that are available with a vNetwork standard switch, and also some of the ways in which you may configure VLANs or even not configure VLANs for a vSphere implementation. We talked about the switches themselves, and then VMNICs and ports and port groups and network services that can be applied to those standard switches, and also some of the policies like load balancing, failover, traffic shaping, VLAN, and even jumbo frame support. I hope this has been informative for you, and I'd like to thank you for viewing.